SMO 2019 Singapore Mathematical Olympiad Senior Section Round 1. We want to consider and solve all problems. If you had any question about the solutions, feel free to send a message to my WhatsApp number in the description and below. And we want to consider the ideas for having next videos. Subscribe my YouTube channel and turn on the bell. Okay, so let's consider the problems. Problem multiple choice questions. Problem number 1. The roots of the quadratic equation x squared minus 7mx plus 5n equals 0 and are m and n the roots. Where m is not 0 and n is not 0, find a quadratic equation whose roots are m over n and n over m. When we have a quadratic equation like this, the product of roots will be here m and n, m n will be c over a. C here is 5n over 1. Also, sum of the roots equals negative b over a. Negative b will be 7n. Here, because n is not 0, we can divide both sides by n, so m equals 5. And here we say n equals 6m. So from first one, m is 5, so n is 6 times 5, which will be 30. Now, and we want to find a quadratic equation whose roots are m over n. M over n is what? 5 over 30, which is 1 over 6, and n over m is what? Is 6. So we know the roots are what? So it will be x minus 1 over 6 times x minus 6 equals 0. You can multiply both sides by 6. It will be 6x minus 1 times x minus 6 equals 0. And then it will be 6x squared. Negative 36 minus 1x, negative 37x. Negative 1 times negative 6 will be plus 6 equals 0. So let's check. This one plus 6. 6 squared. So the answer is D. SMO 2019 Senior Section First Round Problem number 2. Simplify this term. Okay, it is 1 over 3. You can say 7 over 3 is also 1 over 3 plus 6 over 3. You multiply this to the power of 1 over 3 to this. And it will be multiply these two terms. It will be 10 minus 2. Let me write to understand better. It will be 1 over 3. You say, okay, it is root 10 plus root 2 to the power of 1 over 3 times root 2. Root 10 plus root 2 to the power of 6 over 3, which is 2. If we multiply these two terms, it will be 10 minus 2 to the power of 1 over 3, and you can raise it to the power of 2. It will be 10 plus 2 root 20. 10 minus 2 is 8. 8 to the power of 1 over 3 will be 2. It will be 12 plus 20 is 2 root 5. It will be plus 4 root 5. So it will be 24 plus 8 root 5. And the answer is C. If you had any question about the solution, as I said before, feel free to send a message to my WhatsApp number in the description and comments. SMO 2019 Senior Section First Round. Problem number 3. Let A equals 4 to the power of 3000, B equals 6 to the power of 2500, and C equals 7 to the power of 2000. Which of the following statement is true? We should find which of them the order of A, B, C. When we solve these types of problems, the main idea, and it's famous in SMO problems, you should reach something that the powers are equal. So here we can say A is, we consider 504 powers. So it will be 4 to the power of 6 times 5 to the power of 500. B equals 6 to the power of 5 to the power of 500. And C equals 7 to the power of 4 to the power of 500. Instead of A, B, C, we need to check the bases because the powers are equal. So 4 to the power of 6 is 2 to the power of 12 and equals 4096. And This one, 6 to the power of 5. 6 to the power of 4 is 1296. If you multiply it by 6, it will be 36. We have 3, 6 times 9, 54, 57. We have 5, 6 times 2, 12 plus 5, 17. We have 1, and it will be this. So now we will see B is greater than A. Let's check this one. 7 times 7, 49. 7 times 49 is 3. 7 times 4 is 28 plus 6 is 3, 4. 3 times 7 equals 21. We have 2. 7 times 4, 28 plus 2, 30. We have 3. 7 times 3, 21. Plus 3 is 2401. So this is the greatest one. And the next one is this. And the third one is this. So B is greater than A, greater than C. B is greater than A, greater than C. So the answer is D. SMO 2019 Singapore Mathematical Olympiad Senior Section First Round Problem number 4. Log 3 in base 21 equals x. Express log 9 in base 7 in terms of x. There are around 10 important formulas for logs. If you want to know them, as I said before, feel free to send message to my WhatsApp number in the description and comments. One of them is this: log AB, log BC equals log AC. And a special case of that is log AB times log BA. It will be what? AA. It will be 1. So from this one, you can say log A B equals 1 over log BA. So here we know log 321 is x. So log, because of this, if you change 21, 3 is 1 over x. It is what? It is a log 27. 21 is 7 times 3. So we can say 3 plus a log. This is another formula that when you add these two things will be multiplied, equals 1 over x. It is 1, the first one, plus log 7 3 is 1 over x. So we can conclude what? Log 7 3 will be 1 over x minus 1. 1 over x minus 1 will be x 1 minus x. And now we want log 9 7. So you say, okay, log 3 7 will be x 1 minus x. And 2 times this will be, if you multiply by 2, 2 times this will be log 9 7, which is the thing that we wanted. 2x 1 minus x. So the answer, SMO 2019 Senior Section First Round Problem number 5. Suppose that sine x equals 12 over 13 and cos y equals negative 4 over 5, where x is between 0 and 90, greater than equal, less than or equal this. Y greater than equal 90 degree, less than or equal 180 degree. Find the value of cos x plus y. Now here we say, okay, x is in this point, y is in this point because of this. So sine x is what? Is 12 over 13. For this one, we should find cos x, cos y minus sine x, sine y. So we know sine x is what? We find cos x is 1 square root of 1 minus, because we want to know which is plus or minus, it's plus. It cannot be negative. It will be 1 minus 12 over 13 squared, because sine squared plus cos squared is 1. And it will be 169 13 squared minus 12 squared 144, which will be 25. 5 over 13 squared, which will be 13. Cos y here, it's negative 4 over 5. If you use the same thing similarly, it will be sine y. Sine y is positive. It will be 3 over 5. 1 minus this squared. If you consider square root of that, it will be this. Cos x plus y equals cos x cos y minus sine x sine y. Now we say, okay, cos x cos y is 5 over 13 negative 4 over 5 minus sine x sine y. 12 over 13 3 over 5. It will be this. It will be negative 4 over 13 minus 12 over 5. Now, oh, sorry. Here 12 over 13. I shouldn't consider that. Okay, so it will be negative 4 over 13 minus 36 over 13, which will be, so here the denominator will be 65. Because we didn't cancel 5, it will be 65. If we factor from 65, it will be 5 times this negative 20, negative 36, which will be negative 56 over 65. So the answer is this. And the answer is A. SMO 2019 senior section first round short questions problem number 6. Find the largest positive integer n such that n plus 8 is a factor of n cubed plus 13 n squared plus 40n plus 40. Okay, for this problem you should know divisibility. We say okay, n plus 8. These kinds of problem are so much famous and basic. 13n squared, 40n plus 40. We should do something to get rid of n from right side. So we multiply n plus 8 this term to n squared. So it will be n cubed plus 8n squared. And then we subtract. N plus 8 divides 5n squared plus 40n plus 40. So we've decreased the right side, the power of right side, the degree of right side from 3 to 2. Now we say okay, n plus. We multiply this by 5n, it will be 5n squared plus 40n. If we subtract, here subtract, n plus 8 divides 40. So n plus 8 is divisor of 40. The problem says find the largest positive integer n. So when n is largest one, n plus 8 is largest one. So n plus 8 is 40. And n equals 32. So the answer is equal to 32 and all of them are equivalent. So you can say it satisfies the main divisibility and the answer is equal to 32. And SMO 2019 senior section first round problem number 7. Suppose tangent x equals 5. Find the value of 6 plus sine 2x over 1 plus cos 2x. Okay, so tangent x is 5, or we can say sine x over cos x is 5. So sine x is 5 cos x. This one, you say, okay, 6 plus 2 sine x cos x. And this one, we say 1 plus 2 cos squared x minus 1. We can cancel these 2 minus 1. And then we replace sine x with 5 cos x. So it will be 6 plus 10 cos squared x all over 2 cos squared x. And we will cancel both numerator and denominator by 2. It will be this. So it will be 5 plus 3 over cos squared x. And now we know sine x equals 5 cos x. So we know that sine squared x plus cos squared x equals 1. We want to find cos squared x. So we replace sine squared x with 5 cos x squared. It will be 25 cos squared plus cos squared will be 26 cos squared x equals 1. So cos squared x is 1 over 26. So it will be 5 plus 3 over 1 over 26. Here it's 1, so it will be 5 plus 3 times 26. 3 times 6, 18. We have 1. 3 times 2, 6 plus 1, 7. 78 plus 5, which equals 83. So the answer is equal 83. SMO 2019 senior section first round problem number 8. Suppose x and y are real numbers such that we have these two equalities. Find the maximum possible value of x plus 2y. So we consider here, because we have absolute value, two cases. Case 1, if x greater than equal y. So the first equality will be x minus y plus 3x minus y equals 70. And the second equality will be x minus y plus 3y plus x equals 50. Here we can say from first one, you say 4x minus 2y equals 70, and 2x plus 2y equals 50. Then we can divide both sides by 2. 2x minus y equals 35. X plus y equals 25. If we add up these two things, 3x will be 60, so x will be 20, and here y will be 5. And you can check in both of them, they satisfy. So in this case, x plus 2y is what? 20 plus 10, which equals 30. Now, let's check case 2. In case 2, x is less than y, and we check x is greater than equal y. The answers, last answers. The first equation will be y minus x plus 3x minus y equals 70. The problem says x and y are real numbers. Okay. The second case, y minus x plus 3y plus x equals 50. So from first one, they will be cancelled. 2x will be 70, so x will be 35. Here, x and negative x will be cancelled, so 4y equals 50. So we can say y equals 12.5. Now, x plus 2y in this case will be what? 35 plus 2y, which will be 25, equals 60. Look, if this 60 is greater than 30, but here we said y should be greater than x. Y is 12.5 and x is 35. It's not greater than x, so it's contradiction. And we say, okay, the answer is equal to 30. SMO 2019 senior section first round problem number 9. The coordinates of the vertices, let me show this. The coordinates of the vertices of triangle ABCA is 60. It is A. Let me show with green. It is A. B is 0, 8. It is B, and C, X, Y, such that we have this. You can write X minus this one, 8 squared, plus Y minus 6 squared, plus 64, it will be minus 64 plus 16 minus 16 plus 91 equals 0. It will be 70, 80, negative 80, and here, sorry, it's 36. 6 squared, 36, so it will be negative 100. It will be negative 9, so x minus 8 squared plus y minus 6 squared equals 9. So it's a radius with center 8, 6, and the radius is 3, this length. It is our center. Oh, and C is on this point. C can change. The problem says find the largest possible value of the area of the triangle ABC. So you can say, okay, it's C. If you multiply, for example, you can say, okay, the distance of C to AB times AB over 2. We know if I call this one, let me tell it is, for example, C can be any point. For example, C can be here. So if C is this point, let me show it with pink. So it will be what here? I call this one, for example, H. The area of ABC will be CH times AB over 2. AB is what? AB squared is 8 squared plus 6 squared, which is square root of that 10. It will be 5CH. So because we want to maximize area of ABC, we should maximize CH. So we have a line outside a circle. We want to find a point that the distance to this line is maximum. Let me explain for you. Minimum and maximum is what when we have a circle. So it has several proofs. One of them is you say, okay, we want to consider the lines. So you consider the center, draw perpendicular, and extend this from center. Now you say, okay, this O, this. Now I want to say this one, if I draw this one and this one, this point has the minimum distance, this point has the maximum distance. It is X, it is Y. So if you have other points, for example, T here. So if you want to find the distance of T, let me show it, for example, with black. This one, let's draw two perpendiculars. If it is 90, if I draw perpendicular to this, so you can see this length, it is rectangle. This length is this one, it's the minimum one is this case. It is between, for example, xt and yt. The maximum happens, it is t, it is l. The maximum happens when d is y, the minimum happens when t is x. So here you should find the distance. So, and let me tell you, maximum is what and minimum is what? The distance of O from this circle plus R. OL plus R is maximum. OL, this one, minus R, this one will be minimum. OL plus R is what? Is YL. OL minus R is XL. So we should find CH is, if I draw perpendicular to this, and if I call this one L, maximum CH is OL plus R. This is R. It's OL plus R. For finding the points, the distance of point from a line, it has a formula. There are some around, I can say 10-15 formulas in coordinate geometry that you should know one of them at first. We should find the equation of this line that passed from 8, 0, 8 and 6, 0. At first we should say y minus, for example, one of them, y minus 8 equals the gradient. It will be 8 minus 0 over 0 minus 6 times x minus 0. So it will be y minus 8 equals 8 over this negative 4 over 3 x. Now we say if we multiply both sides by 3, it will be 3y plus 4x. Negative 24 equals 0. Now we want to find the distance of O. O is what? 8, 6. If you want the distance of this, you say, okay, you replace this point in this line. It will be 3 times 6, 18, plus 4 times 8, 32, minus 24, over root 3 squared plus 4 squared. Here it will be what? 32 minus 24, which will be 6 plus 2, 8. 8 plus 18 will be 26, and it will be 5. So the distance will be 26 over 5. So CH is what? OL is 26 over 5, plus our radius is what? 3. If we multiply 5 by this, it will be 26 plus 5 times 3, 15. So the answer is equal 11, 1, 2, 3. So the answer is equal to 41. SMO 2019 senior section first round problem number 10. In the figure below, AD is perpendicular to the BC, PQ is parallel to BC, and the triangle PQR is an equilateral triangle whose area in meter squared is equal to length of AD in meter. Find the smallest possible value of the length of BC. Okay, for this problem, we will use, we can say, okay, the problem says it is parallel to this, you consider it is X, and this one, so we call ADH, let me write here, ADH, and I call this one H1. So by using Thayer's theorem or similar triangles, X over BC or X over A equals H1 over H. And this problem doesn't need any important formulas. All the things it's needed are some basic formulas. If you want to learn important formulas that is useful for, there are around 50 important ideas and formulas that are useful from qualifying level up to IMO. If you want it, then let me know through my WhatsApp number. Feel free to send message to my WhatsApp number in the description and comments. So let's consider this case. We know that h1 is what, h is what. So look, this part h2, if you consider, it is equal to altitude of this equilateral triangle. And we know h minus h1 is this part equals to altitude of this triangle. It's x root 3 over 2. Now we can say what? We can say here it's x over a. The problem says what? The problem says the triangle PQR is an equilateral triangle. Area of PQR is what? X squared root 3 over 4 is equal the length of AD, which equals h. So if we cross multiply xh equals ah1, you can replace h with x squared root 3 over 4, and then we can say also it is equal to a times h1. And we say, okay, it's a, h1 is what? Is h minus this from this part. H is what is this? So it will be x squared root 3 over 4, h minus x root 3 over 4. You can divide both sides by, okay, it will be x squared root 3 over 4 minus x root 3 over 4. We can cancel root 3, root 3, root 3, and we can cancel x, we can multiply both sides by 4, we can cancel this, and we can divide both sides by x, so we have x squared equals a times x minus 1. Oh, sorry, here is x root 3 over 2. So if we multiply by 4, we have 2 here. So we should write 2 here. And okay, we can say a equals x squared over x minus 2. The problem says find the smallest possible value of a or bc. So we differentiate from, consider is f of x. So f prime x equals what? 2x times 1 minus x squared. Let me check it again. 2x times x minus 2 minus x squared times 1 over x minus 2 squared. It will be 2x squared minus this x squared minus 4x over x minus 2 squared. So it is equal to 0. We can conclude x squared minus 4x equals 0. So x times x minus 4 equals 0. x0 is impossible, so x equals 4. And here in this case, we conclude a is what? A is 16 over 4 minus 2, 2, 8. And you can check x near this, and you will see a is minimum and maximum. And you will conclude that a is the smallest case, and smallest possible a will be 8. SMO 2019 senior section first round, problem number 11. Find the value of this term. Okay, for these types of problem, you should know and you should memorize the formulas that change product in trigonometric things to plus, addition, or minus, and vice versa. So if we consider product of signs, it will be 1/2. Cos, the difference, it will be 51 minus this cos 12 minus cos sum of them, which will be cos 90. Cos 90 is what? Is 0. So it will be 1 over 2 448 times 1 over 2 times sine 12 cos 12 over sine 24. You can say sine 24 is 2 times sine 12 cos 12. So if we divide, we have 2 here. So the answer is 448 over 4, which equals 112. So the answer is equal to 112. As SMO 2019 senior section first round, problem number 12. In the figure below, the chord AF passes through the origin O of the circle and is perpendicular to the chord BC. So it's perpendicular. It is given that AB is 17, so it is 17. CD is 5. Suppose BE over ED. BE over ED is M over N, where M and N are positive integers, which are relatively prime. What is the value of M plus N? Okay, we draw a perpendicular from O to AB. Then because it is O and it's the chord of this circle, this one will be 17 over 2. This angle, it is B. So this angle is 90 minus B. Then we can conclude what? AO, which is R of this circle, R times cos 90 minus B equals 17 over 2. We can replace cos 90 minus B by sine B, so 2R sine B equals 17. Now, another formula that we can use is what? In a triangle, we know R equals A in triangle ABC. For example, that we have this. Circumradius is A over 2 sine A. You should memorize this formula and it is so much useful. There are around 50 important ideas that are useful from qualifying level up to IMO. If you had any question about them or if you want to learn them, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Now here, we say, okay, we want BE here. R equals BE over 2 sine A. And here we proved R equals what? R equals 17 over 2 sine B. Now we say what? We say BE, we cancel these two, equals 17 times sine A over sine B. Sine A over sine B. We found BE. Let's focus on ED. In this triangle, we draw this line and we can easily prove because it is cyclic quadrilateral. A is CB, this plus this is 180, this plus this is 180, so it is equal to this. So we can say triangle DEC is similar to triangle DAB. And then we say, okay, CD over AD equals DE over BD. So DE equals AD, now let me say BD over AD times CD. CD is 5 and BD over AD, you can say this sine A and AD over sine B times 5. So if you want to know BE over ED, both of them have sine A over sine B, you can get rid of that. It will be 17 over 5. And it is M, and they are relatively prime. M is 17, N is 5. So M plus N equals 17 plus 5, which equals 22. So the answer equals 22. SMO 2019 senior section first round problem number 13. Let P of x be the polynomial that results from the expansion of the following expression. This term, find the sum of the coefficients of x 2k plus 1, where k equals 0 to 9. Okay, so it is P of x, and if we consider the degree of P equals 3 times 5, 15, plus it's 5, it's 20. So it says k0 will be 1, 9 will be 19. So we know P of x equals what? It's the degree is 20, a20 x20 plus a19 x19 plus a18 x18 and 2a2x squared plus a1x plus a0. If you consider P of 1, and the problem wants what? the coefficient of x to the power of odds, all of them. The problem says a19 plus a17 to a3 plus a1 is what? If we consider p of 1, it will be what? It will be a20 plus a19 plus a18 plus 2 a2 plus a1 plus a0. If we consider p of negative 1, it will be a20 minus a19 plus a18 plus a2 minus a1 plus a0. Because we want a sub odd numbers, we subtract these two terms. P of 1 minus P of negative 1 will be what? Will be 2 times a19 plus a17 plus 2a1. So the answer is P1 minus P negative 1 all over 2. Now here let's consider this is P of x. Copy. Paste it here. P of 1 minus P of negative 1 all over 2. If you replace x with 1, 2 plus 3, 5 plus 1, 6, 6 to the power of 5, 1 over 6 plus 1 over 2 to the power of 5 minus. If you replace x with negative 1, negative 2 plus 3, negative 1 to the power of 5, negative 1 over 6 plus 1 over 2 to the power of 5, all over 2. Now, if we simplify this, let's see what we have. Here it's what it's, if you consider common denominator 6, 1 plus 3, 4. 4, 6 to the power of 5, 6 to the power of 5 in denominator and numerator will be cancelled. 4 to the power of 5, which will be 2 to the power of 10. Here, common denominator 6, negative 1 plus 3. 3 minus 1 is 2. Here is what? 3 minus 1 minus 1. It is 0. So this is 0. 2 to the power of 10 over 2, 2 to the power of 9, which will be 512. So the answer is equal to 512. Problem number 14, SMO 2019 senior section first round. Find the value of the following expression. Okay, so there are around 5 important identities. You should memorize them. One of them is this. If you want to know all of them, as I said before, feel free to send message to my WhatsApp number in the description and comments. It's this. Now, if you write, for example, 2, 1 plus 1, 3, 1, 2 plus 1. Also, you can use this with hockey sticks identity, but let's solve with this basic idea. It's 48 plus 1, 49 plus 1. So, it will be what? 1 squared, 2 squared, 3 squared, 48 squared, 49 squared. Because also we have this, so we can say 3 times 1 squared plus 2 squared. Because we have 1 squared, 2 squared, until 49 squared, and 2 times that. So if you add up, it will be 3 times 49 squared plus 2 times 50 squared plus 1 times 1 plus 2 plus 3, 248 plus 49, all over 100, because here we have 100. Now if you use the formula, it will be 100 times 3 times n is 49. 49 times 50 times 2 times 49, 98 plus 1, 99, all over 6 plus 2 times 2500 plus 49 times 50 all over 2. Now, if we simplify, we can simplify. Let me see. Can simplify this 50 by this. It will be 2, 50 here, 50, and 50 here. And you can 3, 3, 2. So we have 1 over 2 here and here. You can factor from 49. It will be 99 plus 1, 100 over 2 plus 2 times 500, 2 times 50, which will be 100. Now, It is 1 over 2, 1 over 2, so you say 49 times 100 over 4, 25 plus 1 over 2, 150. So you factor from 25, it will be 49 plus 2, which will be 51. So the answer of this problem, if we multiply, it will be 25 and 125. 5, 7, 2, 1. So the answer of this problem equals 1275. SMO 2019 senior section first round problem number 15. Let m be the maximum possible value of this term where x is a positive integer. Find the value of 9m. Okay, let's define it is f of x. I want to consider when it is increasing, when it is decreasing. So if we consider f prime x, we know that x is not -1. Let's consider it at first. So if we differentiate from f, it will be 30x minus 3x squared minus 39 times x plus 1 minus 15x squared minus 3x minus x cubed minus 39x minus 54 times differentiate from x plus 1, which is 1, all over x plus 1 squared. Now, we know the denominator is always positive. We focus on numerator. Equals, let's call numerator, for example, p of x equals, let's consider the coefficient of x cubed. It will be -3, 1, 1, negative, negative, plus 1, plus x squared. It will be -3 and plus 30. And here, x squared, -15. Plus x, which will be -39. 1 plus 30 plus 39. And -39, the constant, negative, negative, positive 54. So it will be what? It will be -2. And here it is 15. 15 minus 3, 12. They will be cancelled, 30. And this one minus this one, 14 minus 9, 5. 4 minus 3, 1. So it will be -2 x cubed plus 12x squared plus 30x minus 15. Sorry, it's this minus this plus 15. Now we want to see p of x is the sign of this is equal to sign of f prime. We know x is not -1. We consider this, we at the end we can say at the end we consider, we know that x is not -1 and the problem says what? X is positive integer. So let's see p of x is when 0, because it is differentiate of this. When p of x is 0, f prime x is 0. So if I want to analyze the diagram, I say okay, for -infinity it is positive, it is something like this. For positive infinity it is negative. And I want to differentiate from x, p prime x equals -6x squared plus 24x plus 30 equals 0. And then we divide by -6, x squared minus 4x minus 5 equals 0. So you can say x minus 5. X plus 1 equals 0. So x is 5 and plus 5 and -1. So for -1, 1, 2, 3, 4, 5. And 5, we have 0. So let's check. For -1, it is what? P of x. P of, let me write the rest of that with black. P of -1 here, if we replace, it will be what? It will be 2 plus 12 minus 30 plus 15. -15 plus 14 will be -1. So here it will be -1 here. So we have this, and then For p of 0, it will be 15. So here we have 15, and we know, okay, we have something like this, and it goes to, let me show it a little better, is for example 15. If we have 15 here, it is not exact diagram, but you understand that it happens like what when it is 0. So we should find this point, and because x can only be integer, we should check until here. It is because p prime, it's p of x, it's f prime, relate to f prime. Here is positive, so f prime is positive here. So f is increasing. After this, it is decreasing. So you should check this point and this point, because after that it is decreasing. So for example, if this point is t, if this is t plus 1, if we consider f in these 2 points, so from t to this point, it is plus positive. And then here it is increasing, so it's here. So maybe this is minimum, or maybe it is like this. Then it is minimum. So we should find these 2 points. And for example, you can check for some number. For 5, you know it is 0. For 5, p prime is 0. But it is, you can check, it will be positive. For example, for 10, you can check, you will see p of 10 equals negative 2000 plus 1200 plus 300 plus 15, and it's obvious is negative. So 10 is here. And you can check, for example, 8. P of 8 is what? Negative 2, 8 cubed. 8 is 2 cubed. It will be 29, 210, negative 1024 plus 3 times 2 cubed, 26, and 28, 256 plus 8 times 30, 240 plus 15. Okay, so here you can say, okay, 2 times this will be 512. If you consider negative 512 plus 256, which will be negative 256, it's what? 240, 255, and it will be negative 1. So you understand, probably t plus 1 is 8. So let's check also 7 to make sure. P of 7 is negative 2 times 7 cubed, which will be 343. Because 7 times 49 is this, plus 12 times 49, plus 30 times 7, which will be 210, plus 15. So if we calculate this number, it will be negative 686 plus this number. You can say if this is 50, it will be 600 minus 12, which will be 588. And you say, okay, 588. And if you consider these two numbers, it will be 522. And if you add up these two numbers, it will be 5 plus 8, 13, 1. 2 plus 8, 10, 1, 11, 1. 2 plus 5, 7, plus 1, 8. And it is positive. So you understand it is 7. So you need to check only f of x for 7 and 8. So let me copy this one. So we said it is what? F of x. F of 7 is what? And then the problem says what? The problem says find 9m. You can guess that x should be 8, and the answer is 8, but let's check, because you should find 9 times that, 9 times that. You say, okay, 9 times this will be 9, it will be over 9. 15 times 64 minus 8 cubed, which will be 2 to the power of 9 minus 5, 12, minus 39, times 8 minus 54. And then you can say, okay, it's 30 times 32, which will be this, and this one. 8 times 9, 72. We have 2, 7. 8 times 3, 24 plus 7, 31. And then if we add up these numbers, 4, 2, 6, 6, 2, 8. 5, 1, 6, 6 plus 1, 7. And 3 plus 5, 8. Now if we subtract these two numbers, it will be 9. 10 minus 8 is what? I don't multiply because I want to check with f of 7. I multiply 9 at the end. 10 minus 8 will be 2. 5 here. 15 minus 7 is 8. 82 over 9. So here, if we multiply, it is 82. Now, if we check for f of 7, for 9f of 7, you can say, okay, 9 times 15 times 49 minus 7 cubed, which will be 49 times 7, which will be 343. Minus 39 times 7, 7 times 9, 63. We have 6, 7 times 321 plus 627. Minus 54. And we add by 8. So here, it will be 9, this one. If this is 500, it will be 750 minus 15. And if we add up all these numbers, let's consider these numbers. 3, 3, 6, 6, 4, 10. We have 1, 1, 5, 6, 6, 7, 13 plus 4, 17. We have 1, 1, 2, 3, 3, 3, 6. And over 8. So we can check what 7, 5 minus 5, 8, 6 over 8. So it will be 9. 5, 10 minus 5 is 5. 4, 14 minus 8 is 6. 6 minus 6 is 0. So it will be this over 8. Now, if we check these two numbers, 82 over 9, we want to see which of them is greater. 65 over 8. If we cross multiply 9 times 5, 45. We have 4. 9 times 6, 54. 54 plus 4, 58. 8 times 2, 16. We have 1. 8 times 8, 64. This. So it is greater. It is greater. So this one is greater. So the answer is equal to 82. SMO 2019 senior section, first round problem number 16. Find the maximum possible value of x plus y plus z, where x, y, z are integers satisfying the following system of equations. These two equalities. Okay, so here we will see, if we focus on these two equations, we will see x to z here, 2x to y to z, 2y2. So if I multiply first one by 2, let me write like this, and second one by z, and subtract. Then 2x squared z, 2x squared z will be cancelled, and also it will be cancelled. 216xy minus. If we subtract, we will have minus xyz squared equals 400 minus 50z. Now, if we factor, it will be xy 16 minus z squared equals 58 minus z. Now we can say, okay, xy 4 minus z, 4 plus z equals 50 times 8 minus z. Now we can say, okay, 4 minus z divides 8 minus z, and sorry, we know 4 minus z divides the whole part here. 400 minus 50z. Also, if we can say 4 minus z divides 50z multiplied by 50, it will be 200 minus 50z, and if we subtract, 4 minus z divides 200. For 4 plus z, 4 plus z divides 400 minus 50z. 4 plus z, if you multiply by 50, it will be 200 plus 50z, and if we add up these two things, 4 plus z divides 600. Now from here we know x, y, z are integers, so 4 minus z, and let me tell you something. Here 4 minus z, they are not 0. Why? Because if 4 minus z equals 0, then the right side equals 0, then z equals 8. So we can conclude left side is not 0 because right side is 0, and right side is only 0 for when z equals 8. And if you replace z equals 8 here, you will see it's not okay. So z is not equal to 4 minus 4 because in these two cases, only left side is 0. And so we can write these divisibilities. Now 4 minus z divides 200, so it is a divisor of 200, and we can say, okay, each 0, memorize this, each 0 at the end of the number is times 10, times 10 is times 2 times 5, so we have 2 zeros, 2 squared, 2 here, 2 cubed, times 5 squared, and if you want to know the number of divisors, it will be 4 times 3 times 2, 24. 2 is because of plus minus. Now, okay, we want to write 4 minus z equals, let's write its divisor, plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 6, 7, 8, plus minus 10, plus minus 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Plus minus 20 now, it's 200. So 8 times what is 225? 5 times what is 240? And 4 times what is 200 plus minus 50? 2 times plus minus 100 and plus minus 200. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, plus minus 24. So we've written all of them. Now, we want to see 4 plus z is what, and check 4 plus z must be divisor of 600, and we can reject many of them. If I want to reach from 4 minus z to 4 plus z, let me write rest of that with black. I know that 8 minus 4, because some of them is 8, so 8 minus 4 minus z is 4 plus z. So if I say 8 minus this, so it will be 7. 8 minus minus 1 will be what? 9. So you can also say, because we have plus minus for each number, you can say we consider 8 plus these numbers. So 8 plus 1, 9, 8 minus this, because look, 8 minus minus 1, we should consider an 8 plus minus 1. So we can say, 8 minus minus 1 and 8 minus plus 1. So we can say, okay, it is 8 plus 1 and it is 8 plus minus 1. So we add 8 to each of them. It will be 10, and it will be 6, 12, 4, 13, 3, 16, 0, 18, negative 2 for these, 28, negative 12. Let me write a little better. 28, negative 12, 33, negative 17. For this one, 48, negative 32, 58, negative 42, 108, negative 92, 208, negative 192. So we know the 4 plus z is divisor of 600. If we factorize 600, it has 2, 6, 2, 2, 2 cubed, times 3 times 5 squared. So 7 is bad. 9 is bad because it's 3 to the power of 1. 10 is not bad. 6 we can't reject. 4 we can. 13 we can reject. 16 we can reject because power of 2 is 3. 0 also we can reject because we said 4z is not 4 and negative 4. So in this case, we will see that z negative 4. 18 is 9, impossible. 28 is multiple of 7, impossible. 12, 33, 11, impossible. 17, it's 16, it's 2, 3, impossible. 2, 5, impossible. 58 is 2 times 29, impossible. It has multiple of 7, impossible. It is multiple of 27. It's 2 times 54. 54 is 2 times 27 is multiple of 9, but here we don't have 9. It is negative 2 times 46. 46 223. We don't have 23 here. It's 2 times 104. 104 is 2 times 52. And 52 is 2 times 26. 26 is 2 times 13. It is not multiple of 13. It is 3 times 64. And we can say that 64 is not divisor of this. So we need to check 1, 2, 3, 4, 5, 6, 7 cases. So let me copy this one and check it for these 7 cases. And we should find maximum of x plus y plus z. So if z is 10, then we can say what? xy times 4 minus 10, negative 6. 4 plus 10, 14. It's 58 minus 10 will be negative 2. And, okay, so 4, sorry. It is, let me correct it. For these cases, it is 4 plus z, so z is what? This minus 4. Take 4. The right hand side, 10 is, z is 10 minus 4, 6, 6 minus 4, 2, 12 minus 4, 8, 4 minus 4, 0, 3 minus 4, negative 1, negative 2 minus 4, negative 6, negative 12 minus 4, negative 16. Now, we consider these 7 cases. If z is 6, then x, y, 4 minus 2, negative 2. 4 plus z is 10 equals 58 minus 6, which will be 2. And you can cancel this 0, 0, this y, this 1. So xy will be negative 5. So in this case, if we consider x plus y plus z, it is the maximum case here is x, y, one of them negative 1 and 5, negative 1, 5 and 6. 11, 12. So look, we need to check all of them because we want to only find maximum. I don't check that, for example, is negative 1 and 5 satisfy these two equations? Because I want to find maximum, I write all of them and then at the end I check from the maximum number. If the maximum number is satisfied, we don't need to check all numbers. Z6 we have this. Z2 xy 4 minus z4 plus z6, it's 58 minus 2, 6. We can cancel these two things. So xy is 25. And you can say, okay, for this one, because it's 25 a large number, if one of them is 25, let me copy the equation here. Copy. If, for example, one of them is 25x, here z is positive, 2 times 25 is squared, and xy is positive. It will be greater than 200. So they cannot be 25, so x plus y plus z. The maximum case is 5 plus 5 plus 2, 12. Because 25 is impossible for first equation, left side will be greater than 200. The third case we should consider z equals 8. So xy 4 minus 8, negative 4. 4 plus 8, 12. It's 50 times 8 minus z, 0. So from here we conclude xy is 0. And so x plus y, because xy is 0, we can't say x plus y is maximum of that is what, because, for example, one of them 0, one of them 10,000. So we should check these equations. We can conclude x squared plus y squared, it is 8, it is 0. 8 times this is 200. 200 over 8 is over 225. Because one of them is 0, so x, the other one is at most 5. So it will be 0 plus 5, 5, 8, 13. And let me check. We consider, for example, x is 5, y is 0, z is 8. The first equation will be correct. Also, the second equation will be 2 times, it is 0, 2 times factor from 225, 50. So we see that it is possible. Okay, so 13 is possible. Now we understand 12, 12. We don't need to check these cases. Let's consider where z is 0. If z is 0, then xy 4, 4, 50 times 8. We cancel 8, 2, and then 2, 25. And then xy is 25. So the first equation will be correct. The second equation, x squared plus y squared is what? 50 over 225. And if we want to satisfy x and y, x can be plus minus, one of them plus minus 1, the other one 0, or plus minus 4, 3, plus minus 3, vice versa. In both cases, we see that xy is not 25. So we reject when z equals 0. We've checked 4 cases. Now let me copy this, the rest 3 cases. So paste it here. We've checked until this. Let me also copy this. So if z is negative 1, then xy 4 minus minus 1 will be 5, 4 minus 1, 3, 58 minus minus 1, 9. We can cancel these 3, we can cancel this 10. So xy is 30 in this case. And we can see that, okay, so if we want to check this one, xy 5, this 10, 30. Okay, so x squared plus y squared times negative 1. It will be 8xy 240. 200 minus 240 will be negative 40 because we have negative 1. It will be 40. So if you check this one, for example, if one of them is 25, 15, impossible. 36, 36, 4 is possible. So x plus y. Also, you can check other cases. Only this case is possible. X plus y plus z is at most 6 plus 2 plus negative 1 will be 7. So we don't need to check this case that is possible because we found 13 that was possible. Now let's check when z equals negative 6. xy 4 minus minus 6 will be 10. 4 minus 6 will be negative 2. 58 minus minus this will be 14. Now, if we cancel these two, it will be 7. This 10, this 10, and xy will be what? Negative 35. And, okay, so if we replace here, x squared plus y squared times negative 6 will be 200. 8 times this, if we take it to right side. Okay, it will be 280. 8 times 5, 40. We have 4. 8 times 3, 24 plus 4, 28. We take it to right hand side, so we can say, okay. X squared plus y squared, if you divide it, will be less than 0. So that's contradiction. If the last case, we should check z equals negative 16. xy times 4 minus z will be 20. 4 plus z will be negative 12. It will be 58 minus z will be 24. And we can cancel these. 2 negative 12 will be 12. 24 negative 1. So xy will be negative 5. And if we replace in first one, x squared plus y squared times z equals what? 200 minus 8xy. 200 minus 8xy will be plus 40. And again, we will see x squared plus y squared is less than 0 because it's negative, it is positive, and that's contradiction. So the only case that also it was maximum and we found answer x5, y0, z8. And we can check in both of them that it's correct because it's 2 times 25, 50, 0 here. Also, it is 8 times 25 plus 0, which will be 200 this, and x plus y plus z in this answer is 13. So the answer of this problem is equal to 13. If you had any question about the answer of this problem or the other problems, as I said before, feel free to send a message to my WhatsApp number in the description and comments. SMO 2019 first round senior section problem number 17. Find the remainder when 10 to the power of 43 is divided by 1 to 6. Okay, so when we want to find it mod 1 to 6, we prime factorize 1 to 6. It is what? It is 9 is multiple of 9. 9 times 1 times 36. It will be 4. So it will be 2 times 3 squared times 7. Now we should find 1043. Mod 2 is 0. It's obvious. Mod 9 is what? Mod 9, because 10 is 1 mod 9, so it will be what? And if we want to consider mod 3, 10 to the power of 43 mod 7. You can say it is 3 to the power of 43. And we can say it is 3 squared mod 7 is 9. It's all of them mod 7. So 3 squared is 9. It will be, so let me write like this. 3 squared to the power of 21, 42 times 3. 9 mod 7 is 2. 221, 3. And then you say, okay, 2 cubed is 1. It's 8 to the power of 7. 2 cubed times this, it is 1. It will be 3. So it is 3 mod 7. So this number is 3 mod 7. So because it is 1, I want to find mod 18. You can add by 9, it is 10. So we can say 10 to the power of 43 is 10 mod 18. And it's 0, 1 mod 9. So the idea is to reach same number. Also, it has another solution if you want to learn all of them, or if you had any question with this solution, feel free to send message to my WhatsApp number in the description and comments. Now, let's consider this one. 1043 equals 3 mod 17. So we can do here, we can write, for example, 10 plus 18 to reach the same number, or, it's mod 7. Mod 7. One way is this. Here, let me also teach you the other solution. You consider it is A. So you say A is 10 mod 18. So A is what? 18q plus 10. And you replace it here. It will be 18q plus 10 is 3 mod 7. So 18q is negative 7, which is 0 mod 7. So you conclude 7 divides q. So because 7 divides q, q is 7q prime. If you multiply 7 by this, it will be 1 to 6q prime plus 10. So here also the answer is 10, the remainder. Also you could add 3 plus 7, 10. 10 is same for both of them, so the answer is 10. These two solutions are useful. Sometimes it is better, sometimes this one is better, sometimes both of them works, like here. SMO 2019 senior section first round problem number 18. Okay, we have this equality. If x is 49 and y is a positive integer, find y. So if you consider this one, for example, it is a, this one b, it is a, and it is b. So it is what? A squared plus 4b squared. You take it all things to the left hand side. 4ab equals 0. So it is what? It is equivalent that a minus 2b squared equals 0. So a equals 2b. So we can say what? Log x in base 2 equals 2b, which is 2 log base 2 log y in base 3 of this number. And okay, in logs, there are around 10 or 15 important formulas. If you want to learn them, as I said before, feel free to send a message to my WhatsApp number in the description. So you take 2 inside, it will be log y in base 3 squared. Now you say 2 to the power of these terms, it will be x, and the right side will be log y 3 squared. X is what? X is 49. Now we want to see, the problem says y is a positive integer. If y is 1, it is 0. Y less than 1, it is negative y. Because y is greater than equal 1, y is a positive integer. So we can say it is a non-negative number. So we can say if we use square root, it will be 7. Now if we consider 3 to the power of this, it will be y equals 3 to the power of 7. 3 to the power of 6 is 7 to 9 times 3. It will be 3 times 9, 27. We have 2, 3 times 2, 6 plus 2, 8, 3 times 7, 21. So the answer is equal to 2187. SMO 2019 senior section first round, problem number 19. The figure below shows a rectangle ABCD with AB 16, BC 15. It is 15, so it is also 15. Let P be a point on the side BC such that BP is 7, so it will be 8. And let Q be a point on side CD such that CQ is 6, so it will be 10. Find the length of AR in centimeter, where R is the foot of perpendicular from A to PQ. We should find AR. So let me call this one X. So here, if we find area of APQ, and we easily can find PQ by Pythagoras theorem in this triangle, 8 squared 64, 6 squared 36, plus if you add up them, they will be 100. Root of that will be 10. So PQ is 10. If we find area of APQ, then the problem will be solved. So area of this triangle is what? 15 times 10 over 2. It will be 10 over 2, 5 times 15, 75. This one. This times this over 2, 16 over 2, 8 times 7, 56. This times this over 2, 4 times 6, 24. And we can say, okay, area of APQ equals, if you consider area of rectangle, 16 times 15 over 2, 16 over 2 is 8, 8 times 15 is 120, minus 56, minus 75, minus 24. So it will be 120 minus 4 plus 6, 10, 10 plus 5, 15. We have 1 plus 2, 3, 3 plus 7, 10, 10 plus 5, 15. And sorry, here when we multiply 15 by 16, I shouldn't divide by 2 because it is, let me correct it. I should write 240. So it will be 240 minus this, 240 minus this. So 10 minus 5 is 5, then is 3. 13 minus 5 is 8. 1 minus 1 is 0. So here the answer of this area is 85. 85 is what? Is 10 times x over 2. So it will be what? 85 will be 10 over 2, 5x. So x is 85 over 5, which equals 17. So the answer is 17. SMO 2019 senior section first round, problem number 20. A sequence x0, x1, x2, x3, and so on of integers satisfies the following conditions. x0 is 1, and for any positive integer n greater than equal 1, absolute value of xn minus 1 equals absolute value of xn minus 1 plus 2. Find the maximum possible value of 2019 minus x1 plus x2 plus 2 plus x 2018. Okay, for solving this problem, we do two things. We give an example, find an example, and then also we prove. So we say, okay, our answer is between what two things. So I say maximum of this is equivalent to minimum of, because 2019 is constant, minimum of x1 plus x2 plus x28. So we should find minimum of this number, and I consider minimum of this number, for example, t. So let's say something. We can find answer in terms of t. Answer is 2019 minus t. So we should find t. So if we find any example, which of them we prove? If, for example, you find t with an example is 100, because you want to find minimum, then you say, okay, it is that or less than or equal. And with proof, we should say, okay, it is at least what? So we should find exact number. It is the way that you should prove these kinds of problem also in round 2 up to IMO. So here we say something. Okay. So I find an example. I say, okay, x0 is 1. If I replace 1 here, 1 plus 2, 3. x1 can be negative 2. If I replace negative 2, it will be 0, so x2 is 1. x3 negative 2, x4 1, x5 negative 2, x6 1, 2, x20 17 negative 2, and x20 18 positive 1. And if we consider these numbers, each of them will be negative 1. So in this case, in this example, we have 2018 over 2 times negative 1. So minus 2 plus 1 is negative 1. It will be negative 1009. So we found an example with negative 1009. Now I want to prove t is always greater than equal negative 1009. So let me tell you how I prove. x0 is 1. I show this diagram. From 1, you can go to what? You can go to 4. Or you can go to what? You can go to, it is x0. You start from here. Or you can go to, let me tell you something here. From this equation, we can conclude two things. If they have same sign, let me write rest of that with black. Xn minus 1, for example, if they don't have same sign, it will be this minus 2. So sum of them will be 1, negative 1. If they have same sign, x minus, so it is the first case, xn minus 1 plus 2, so xn is xn minus 1 plus 2. So here, for example, when we have 1, it will be 3. It can be negative 2 or 4. Negative 2. Now, for example, if it is negative 2, the next one will be 1. So we have, we can go from this or this to this. But if you go to 4, then it will be 6. The next one is what? 7. Or instead of 7, you can say, okay, it is 6. It can be negative 5. As you can see, these numbers are the numbers mod 3 or 2. And we can easily prove, because in this case, remainder mod 3 will be constant. Xn minus 1 is mod, let's say, suppose xn minus 1 mod 3 is 1. In this case, xn and xn minus 1 have the same remainder because 3 is congruent to 0. Also, in this case, you say, okay, xn is congruent to negative 1 minus xn minus. It's negative 1, negative 1, negative 2. Again, it will be 1. So we understand we have the numbers that mod 3 or 1. So let me write some of them. 7. So 7 can go to a number, the sum of them is negative 1, negative 8. And also from negative 8, you can go to negative 5 or this happens. We can check negative 8 plus 2 will be negative 6. It is 6. So it can be 7 or negative 5. So we concluded these things. So our diagram will be this, for example, 10. Then we have 2, and you can write it's 3k plus 1. Replace it here. Some of them is negative 1 or is something plus 3. And it will be what? Negative 11. Now, I want to say what? I want to say I consider also x0. I consider x0. I want to find x0 plus x1 plus 2, a number, any number. For example, x2018. And because I know x0 is 1, I know if I find the minimum of this, because minimum of this is t, so it will be t plus 1. So I start from here. I say, okay, I have 1, then I can go to 4 or negative 2. So I want to say what? I want to say if we start from x0, okay, I want to say something. If 1, we start from 1 x0, then let me call this one minimum of d is, for example, h. I want to say if I start with 1, number of 1s always is greater than equal number of negative 2. And then I want to say number of 4 is always greater than equal number. The key point of the proof is this. Is greater than negative 5. Number of 7 is greater than equal number of negative 8, and so on. So if I prove this, I can say if I consider x0 plus x1 plus x2 plus x 2018. So I say what? I say number of 1 is greater than equal number of 2. So if we consider, for example, suppose we have some 1s, some negative 2s. Some 1s, some negative 2s. And for example, a1 times. So if I prove this, I want to say why the problem will be proved, and then we focus on proving this. And then, for example, you say 4 negative 5, 4 negative 5, 2, and we will see all of them will be negative 1. All of them will be negative 1, negative 1, negative 1, negative 1, also if you consider anything. So at the end, we have all pairs. Because we have odd 0 to 2018, we know that we have some other numbers that they are not pair. So if you have any number, it must be positive. Because if we have, for example, negative 2, again, so we know the number of 1s is greater than equal negative 2. So again, we consider pairs. So some positive numbers. So it will be some negative 2 plus some positive numbers. So x0 plus x1 plus x 2018. So suppose that we have k pairs of negative 1. Or for example, we had k, for example, t pairs or s pairs of negative 1. It will be what? It will be the minimum will be negative s plus some positive cases. Because we have at least one, we have odd numbers here. We have at least one number, and it is at least 1 because it's positive. Negative s minus 1. We know s is at most what? We know 2s are the numbers here is at most 2019. So because it is odd, we can say 2s is at most 2018 because s is integer. So s is at most 1009. So here we can say negative s is at least negative 1008. And plus 1 will be, sorry, negative 1009. Plus 1 is negative 1008. So we found minimum of this is negative 1008. So because we have plus 1 here, take it left hand side, it will be negative 1009. And then we prove this part. But now we should prove what the thing I told you here. Why number of positive ones is greater than equal to number of negative 2. Let me prove this part. Let me copy and prove it. So if we prove this, the last answer will be negative 1009. No, last answer, no. T will be this. If I prove this, and it will be 2019 minus this. So it will be 2019 plus 1009, 9 plus 9, 18. We have 1. 1 plus 0, 1 plus 1, 2. 0 plus 0, 3. So if we prove this, the thing we want to prove here, then we can say, okay, the answer is 3028. So let's prove this one. Okay, so here I know I start from x0, that is 1. So I want to say, for example, the first one, let me tell you how you prove. We consider at first this one, and then we generalize our proof. And we can say, okay, number of, for example, 3k plus 1 is greater than equal number of, some of them is negative 1. Negative 3k minus 2, and we know 3k plus 1 is positive, at least 1. So if we start from 1, we know we have in the beginning we have 1, x0 is. So if we don't see negative 2, that's okay. But if we see negative 2, we know after negative 2 only we see 1 again. So here until here we don't have any negative 2. Number of 1 is strictly greater than negative 2. Here it is equal. So again here, because after each negative 2 we have 1, always the number of 1 is greater than equal number of negative 2. Now it was obvious because here it was a special case. Now let's prove for 4. So I say what? I say we are, for example, let me write the rest of that with pink. We are here. If we want to reach, if number of negative 5 is 0, so it will be solved because it's also at least 0. But if we see negative 5, look, the first time you can reach negative 5 is you reach from 4. Because, for example, if you want to reach from negative 8, you should see what? Negative 7. And you can consider it is like a circle. If you want to reach negative 8, you should see 7. And because you start from here. And okay, so because always you go to right or you have something like this. So if we reach negative 5, we will reach to this. So when we reach this, we see a greater number here. So when we see a greater number here, because all directions are to the right, we see 4 before. So negative 5. So we see, for example, 4, negative 5. Now again, I want to say that before, if I see again negative 5, between them I see 4 at least once. So if I don't want to see 4, so I am here 5, I don't use this one. So I can go to right. If I go to right, only I can use these two things because I don't want to go to 4. So I have, for example, you can consider it is somehow like circle, and you are in a smaller radius and you can't go to negative 5 again. So here you should see 4. You can use this proof also. You can generalize this idea for other numbers with this diagram. If you want to know how to write, for example, it is round 1. But if you want to know how to write this, if it was in round 2, and the other proofs are like this. You consider each one, for example, 3k plus 1. You say, okay, it's 3k plus 1. We have negative 3k minus 2. And you start from 1 here, and you can say again, okay, we have something like this. You say, if I want to see this, at first I've seen this. Because if I don't see this, so before that, you should see a larger number here. It means that you've seen another number here, so you've passed. If you don't want to pass from 3k plus 1, if you don't want to see this, so you can't use this, let me tell you exactly how you should prove. For example, in the beginning, I want to say if I see 3k plus negative 3k minus 2, if you reach this, you see 3k plus 1. If you use contradiction, you can say, okay, suppose I don't see this, so I don't have any of these things. So when I don't have any of these things, because all the directions are to the right, so you say you can erase all of them. So you can erase all these things because you don't use these things. And you can erase all of them, then you can erase all of them, then we don't have any path. Also, you can erase this. We don't have any in degree or any income to negative 3k minus 2. You can't see negative 3 from no one. You can reach negative 3k plus 1. That's contradiction. Again, you can say, okay, I see this. Again, if I see this one again, by the same proof, similarly, you can say, again, I will see this number between them. So we've proved always the number of 3k plus 1, which is at least 1, is greater than equal number of negative 3k minus 2. And if we prove this, the last answer is 3028. If you had any question about the answer of this problem or also the solution of other problems, if you wanted to know how to write down the proof of your on your answer sheet, for example, in round 1 or IMO higher levels, as I said before, feel free to send message to my WhatsApp number in the description and comments. SMO 2019 senior section first round problem number 21. Consider a square. So let me show this. Okay, consider a square ABCD on XY plane where the coordinates of its vertices are given by A 13, 0, it is A. B is 23, 13, B is this, C is 10, 23 is this, and D is 0, 10. Okay, so a lattice point is a point with integer coordinates, okay? Find the number of lattice points in the interior of the square. For this problem, we should use, it's a famous theorem, and it's useful in this problem, also in other problems. This problem is easy for if you use Pick's theorem. If you want to learn these theorems, useful theorems in SMO from qualifying level up to IMO, as I said before, feel free to send message to my WhatsApp number in the description and comments. So here it says the area ABCD equals I, which is the number of inside this quadrilateral, plus B is the number of points on boundary of this quadrilateral over 2 minus 1. So here the problem says it is a square. So easily, because it is 13, it is 10. We can find the area. Area is what is AD squared. It's 13 squared plus 10 squared by Pythagoras theorem. It is this. Now, we want to find I, so we should find the points on boundary. So here, if you pay attention, it is 10, it is 13. I want to, if you consider each of them, the length here is, let me show with green, the length here is 10, the length here is 13. Here it is 10, again it is 13. And this one, let me show with dotted lines. Okay, and this one. Okay, this length is 23 minus 13, 10. This length is 13. This length is 10. This length is 13. So there are similar congruent triangles. For this one, I want to consider how many points do I have. That there are lattice points. So let's consider one of them. I say, okay, this one, the length here is 13, the length here is 10, and then we consider what dotted line. Here it's this. So you say, okay, suppose that it is, for example, this length is A, this length is B. If we use Thayer's theorem, or it is parallel to this, or similar triangles, this triangle is similar to this, A over 10 equals B over 13. So A over B equals 10 over 13. You can't simplify 10 over 13. It is in lowest terms. So A and B cannot be any number here from 1 and to 9. So we don't have any points like this. So all points on boundary are the vertices of these squares. So it will be what? B will be 4. Let me write the rest of that with blue. 4 over 2 minus 1. Now, we have one equation, one variable, and we can find I, the number of lattice points in the interior of the square. So 13 squared is 169 plus 10 squared is 100 equals I plus 4 over 2 is 2. 2 minus 1 is 1. This part will be 269. So I equals 268. So the answer of this problem is equal to 268. As SMO 2019 senior section first, round problem number 22. So 11 distinct chemicals C1 to C11 are to be stored in 3 different warehouses. So consider the first warehouse, second warehouse, and third warehouse. So for example, X here, X chemicals here, Y here, Z here, and X plus Y plus Z equals 11. Each warehouse stores at least one chemical, a per CI/CJ of chemicals where I is not equal to J is either compatible or incompatible. Any two incompatible chemicals cannot be stored in the same warehouse. However, a pair of compatible chemicals may or may not be stored in the same warehouse. Find the maximum possible number of pairs of incompatible chemicals that can be found among the stored chemicals. Okay, so because we want to maximize the incompatible chemicals, we say, okay, if we consider any elements here, we consider between them it's incompatible also between these, because if inside a warehouse all of them should be, all pairs should be compatible, and also these cases. So the number of pairs of incompatible, so if I call this one for example n equals xy plus yz plus xz. So I want to say if I want to maximize this, and the difference of each of them is at most 1. Because if, for example, suppose without loss of generality x, y, z, for maximizing n, I want to say x minus z is at most 1. Why? Because let's prove it by contradiction. Suppose, for example, x minus z is at greater than 1. So because there are integers, it is at least 2. Now we have what? We have, for example, x, y, z. Now change x to x minus 1, z to z plus 1, and y. Let's see what changes do we have. In this neo n, we have x minus 1 times y plus y times z plus 1 plus x minus 1 z plus 1. Now here we can say, okay, we have x, y, y, z, z, x. Here, if you pay attention, you have negative y and positive y. They will be cancelled. xy plus yz plus here we have xz plus x minus z minus 1. And here we said x minus z is at least 2. So it is at least 1. So it is greater than this case by doing this. So if we consider the maximum case, the difference should be at most 1. So we have 3 integers. Some of them is 11. Their maximum distance is 1. So the only possible case you can see it is 3, 4, 4. We don't have any other possible cases because, for example, all of them cannot be equal. If you consider 11 mod 3, so look, we have 2 cases. For example, we have only x and x plus, let me call, for example, a and a plus 1. If all of them is a, then because the difference is at most 2. If all of them is a, 11 should be multiple of 3a. If we have 2a and 1a plus 1, then some of them will be 3a plus 1. 11 must be congruent to 1 mod 3. But 11 is 2 mod 3, so you have a and a plus 1, a plus 1. This idea is so much useful in also other problems. So you say 3a plus 2 is what is 11. So 3a is 9, a is 3. So we have 1, 3, 2, 4. So we have this. And now if we calculate this, xy will be, because we said x is greater than equal y greater than equal z, we say 4, 4, 3. So xy will be 16. yz will be 12, xz will be 12. 12 plus 16 will be 28 plus 12, which is 40. So the answer of this problem equals 40. If you had any question about the idea that we've used here, also it is useful in many problems that we have, for example, a1 choose 2, an choose 2, and we can solve many harder combinatorics problem. If you want to know them and want to learn completely, as I said before, feel free to send message to my WhatsApp number in the description and comments. SMO 2019 senior section first round problem number 23. Let k be a positive integer and let the function f be defined as follows. F of x equals pi to the power of x over pi to the power of x plus pi to the power of 2k minus x. Suppose the function g of k is defined as follows. G of k equals f of 0 plus f of k over 2019 2 f of 2k, which is 43.8k over 2019. Find the greatest positive integer n such that g of k is greater than n for all k greater than equal 1 and g of k is greater than equal n. For solving this problem, we should use a very famous idea that also is useful in some IMO problems, International Mathematical Olympiad. It's Gauss idea. The idea is what? For example, do you know how we add 1 to 100? If you want to find the answer, the idea is write it in reverse order, and sum of each part 1 plus 100 is 101. So you say we have 100, for example. If it is a, it is a. So you say if we add up all these terms, we have 100. Each of them is 101. So a is 100 times 101 over 2. Here again, we want to use the same thing. We say, okay, it is f0 and it is f2k. Consider this and this one. Let me write. G of k is what is f of 0 plus f of k over 2019. Let me erase this part. I just want to remember this. Plus f of 2k over 2019 plus f of 3k over 2019. And if I write gk in reverse order, it will be f of 2k plus f of 4037k over 2019 plus f of 4036k over 2019 and so on to reach the last terms f of 4037k over 2019 plus f of 2k. And here it will be f of k over 2019 plus f of 0. Now, as you can see, the thing inside, for example, if I consider, let me write the rest of that with green. If I consider this fraction m, I can easily see that sum this plus this will be 43.8k over 2019. It will be 2k, so it is 2k minus m. I want to see that f of m can be any of these numbers. F of m plus f of 2k minus m is what? Here, if I replace, the first one will be pi to the power of m over pi to the power of m plus pi to the power of 2k minus m plus pi to the power of 2k minus m. Replace x with 2k minus m over p2k minus m plus p2k minus 2k minus m will be m. So as we can see, both denominators are same, and this plus this equals the denominator, it will be 1. So we understand what? We understand 2gk, each per will be 1, 1, 1, 1. How many terms do we have? 0 times k, 1 times k, 2, 43, 8 times k. So 0 to 43, 8 will be 43, 9. And if you consider g of k, it will be 39 over 2, it will be 20119 9.5. So the problem says what? Find the greatest positive integer n that it is greater than equal n. So n should be what? N should be 2019. So the answer of this problem is equal to 2019. This idea is so much useful. Also, there is another IMO problem you can solve by this idea. If you want to know that or want to learn other ideas, as I said before, feel free to send a message to my WhatsApp number in the description and comments. SMO 2019 senior section first round problem number 24. Okay, some students sat for a test. The first group of students scored an average of 91 marks and were given grade A. So we consider their scores are S1 and the S2, for example, S1 plus S2, 2SP, the number of them, over P is 91. So the sum of them equals 91P. The next group, W1, consider their scores are W1 to WAD. So their scores are, there's average is this. So you can say W1 to WQ over Q is 80. So it will be ADQ, and third group or last group of students scored an average of 70. So we consider T1 plus T2, sum of their scores, plus TR, average is 70, so some of them will be 70 times R. The number of students in all groups are prime numbers, so P, Q, R are prime numbers, and the total score of all the students is 1785. So 91P plus 80P, 80Q plus 70R equals 1785. Now the problem wants what? Determine the total number of students. So the problem says what is P plus Q plus R. Okay, so if we consider this equality, it is multiple of 5, multiple of 5, multiple of 5, so it must be also multiple of 5. So 5 divides 91p, because 5 doesn't divide 91 by Euclid's lemma. You can say 5 divides p, because the problem says pq are on prime numbers, so p equals exactly 5. So ADQ, let's divide this equality by 5. It will be 91 plus 16q plus 16, yes, plus 114r equals 3, 5, 15, 28, 5, 35, 7. So we can conclude 16q plus 14r equals 357 minus 91. 7 minus 1 is 6. 15 minus 9 is 6. It will be 266. Now we can divide both sides by 2. 8q plus 7r equals 133. Now here we can say 133 is multiple of 7. It's 7 times 1, 63, 19. So it's multiple of 7, multiple of 7. So it is also multiple of 7. So we can say 7 divides 8q. So by Euclid's lemma, because 7 and 8 are relatively prime numbers, 7 divides q. From assumption of the problem, q is prime. So q is 7. And we can divide both sides by 7. Then I have 8 plus r equals 19. Now I say, okay, r equals 19 minus 8, which is 11. The problem says what? Find p plus q plus r. P is what? P is 5. Q is what? Q is 7. R is what? R is 11. So 11 plus 7 will be 18. 18 plus 5 is 23. So the answer is equal to 23. SMO 2019 senior section first round problem number 25. Suppose a and b are positive integers satisfying a squared minus 2b squared equals 1 if 500 is less than a plus b less than 1000. Find a plus b. Okay, it is Pell's, these types of equation is Pell's equation. So when we want to solve, you should know this, how to solve this, but I explained this a little. If you had any question, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, for solving these problems, we want to find at first, let me say, for example, u squared minus 2b squared equals 1. We should find answer uv that are positive integers and u plus. Here it's v root 2 is minimum. You shouldn't consider 0 because it has one answer, obvious answer, 1, 0. But you should find u and v here. 1, 0 is obvious that u and v are positive integers and satisfy this, and it should be minimum. If we check, for example, u1 is impossible. 2 squared 4 minus this u should be odd. So 3 squared 9. If we consider u3, 9, and it will be 9 minus 1, 8, 8 over 2, 4, and v equals 2. And you can see that 3 plus 2 root 2 is the minimum case. Now, there is a theorem that says if we want to find any other answer, a plus b root 2 equals 3 plus 2 root 2 to the power of n. And you can consider, for example, here a and b are positive. So If you change a to negative, b to negative, it will be okay for in general case. But here the problem says a and b are positive integers, so we consider only these types of answers. Now, for example, we should find what? We should find this, and we know a plus b should be greater than 500, less than 1000. So, for example, if I consider 3 plus 2 root 2 to the power of 4, it will be what? It will be, you should know binomial theorem. 3 to the power of 4 plus 4 times 3 cubed times 2 root 2 plus 4 choose 2, which is 6, 3 squared 2 root 2. If you had any question about the solution, as I said before, feel free to send message to my WhatsApp number in the description and comment. So 4 times 3, 2 root 2 cubed plus 2 root 2 to the power of 4. So it will be 81 plus, it is what? It is 27. And this is what? 54. 4 times 54, 4 times 4, 16. We have 1, 4 times 5, 20. It is this plus. It is 9. This one will be 2 root 2 times 2 root 2, 4 times 2, 8. 8 times 9, 72. 6 times 72. 6 times 2, 12. 1. 6 times 7, 42 plus 1, 43. And okay, here we will see what we will see. It is okay. 2 root 2, 2 root 2, 2 root 2. 2 times 2 times 2, 8. Root 2 root 2, 2. 16 root 2. And here it will be 48 root 2. 4 times that. 4 times 8, 32. We have 3, 4 times 4, 16 plus 3, 19. Root 2 plus this. 2 times 2 times 4, 2 to the power of 4 is 16. Root 2 to the power of 4 is 4. 4 times 16, 64. So here we can see that some of them, if we calculate 4 plus 2, 6, 6 plus 1, 7, 6 plus 3, 9, 9 plus 8, 17. We have 1, 1 plus 4, 5. Plus, this plus is 6 plus 2, 8, 1 plus 9, 10. We have 1, 1 plus 2, 3, plus 1, 4. So it will be this. So here, if we add up, it is A, as we said here, it is A, it is B. So A plus B is what? 8 plus 7, 15. We have 1, 1 plus 0 plus 7, 8, and 4 plus 5, 9. So this is between 500 and 1000. If, for example, we check 3 plus 2 root 2 to the power of 3, we will see it will be greater, a plus b will be less than 500. If we check for 5, we will see that the answer is greater than 1000. So the only case that satisfies the condition of the problem is when n equals 4 and a plus b is 985. Okay, I released many years, many sections, around 1, round 2 of SMO problems for Singapore Mathematical Olympiad. You can use them also. I released IMO, International Mathematical Olympiad problems, IOI, International Olympiad in Informatics. You can use them in my channel. And also, I will release USA Mathematical Olympiad like AMC, AME, USAMO. You can use them also for BMO, British Mathematical Olympiad. So, to subscribe my YouTube channel, turn on the bell to have next videos. And also, if you had any question about the problems, answers of any exam, as I said before, feel free to send message to my WhatsApp number in the description and comments. And also, there are around 50 important formulas in geometry, 50 important ideas in combinatorics that are useful from qualifying level up to IMO. If you want to know them, feel free to send message.